Okay, so we are going to review slope-intercept form because we're going to use this to write an equation of a line, although we're going to use it in a slightly different way than we have in the past. So if you remember slope-intercept form, we have y equals mx plus b. Again, I know I've said this on quite a few other videos. It is going to be very helpful to commit this to memory. This is not going to go away. This is going to continue to come up all throughout high school math and quite a few different topics in the mathematics. So you want to know this equation. It makes it very easy to graph a line. So we have x and y. Those are our input and our output. We always have a coordinate that is x and then y. So remember, that's the ordered pairs. When we see a coordinate like this, it always goes x coordinate, then y coordinate. Always, always, always. That's why they're called ordered pairs, because they're in order. So that's what x and y stand for. M stands for the slope, which is, the vertical change compared to the horizontal change, or in easier terms, rise over run. So how do I go up or down? Do I go right or left? It's literally what we're looking at for slope. And then the number that's being added or subtracted, which we note as a b in the formula, is the y-intercept. So this is where the line crosses the y-axis. This is our starting point, always. So if we look at this equation, we have y equals negative 2/3 x plus 4. So I'm going to identify my y-intercept, which they also put down here at the bottom. So I'm going to go to the origin, and I go up to 4, and I put a point. I go up to 4 because it's a positive 4. So this is my first point, my starting point. From here is where I use the slope. So I look at this and I see negative 2/3 is my slope. So they've identified it here, and they go -2, +3. It's rise on the top, run on the bottom. If you don't see a fraction, which down here we can actually see slope is not a fraction, it just means that the bottom, the run, will be 1. But if you see a fraction, you already know what your rise and your run are. So rise is just an easy way to remember up and down. So if it's negative, that means I'm going to go down 2. And if it's a +3 for run, I'm going to go to the right 1, 2, 3. So you do want to understand up is positive, down is negative. Right is positive, left is negative. You need to understand those basic concepts of the coordinate grid to graph this correctly. So then you put a point here, and then you can connect and you make a line. So this is the basics of understanding the slope-intercept form of an equation. So now we're going to write an equation for a line passing through the point 4, -3, and has a slope of -3. So in the past, we've been given the slope and the y-intercept. Well, now we're being given the slope and a point. So we can still use this slope-intercept form. We're just going to use it slightly different because now I'm being given different information. So now I'm being given x and y and m. So I'm still being given information that's in the equation. I'm just not being given m and b. I'm given y, m, and x. In order to write the equation, I need to know what m and b are, because remember, when we rewrite the equation, the final equation has to have x and y in it. Those are our variables that change. But once we know what the slope is for the line, it will always be the slope for that line. Once we know what the y-intercept, it will always be the y-intercept for that line. Now, of course, every single line has its own y-intercept and its own slope. So you have to figure that out for every single one. So what we're going to do is we're going to use x, y, and m to find b, that y-intercept. So y equals mx plus b, I'm going to plug in what I have. So y is -3, m is -3, and x is 4. I don't know b, so I'm just leaving it plus b. So now we're going to solve, and we're going to figure out what b is. So first I'm going to multiply. I'm going to simplify this side. So I have -3. Oop, I need to bring that down a little bit so it's not so bold. -3 equals -12 plus b. All I did was multiply here. Now I want to get b all by itself, so I'm going to take this -12 and I'm going to add it to both sides. So anything minus itself, -12 plus 12, is going to be 0. So that cancels out, which is what we want. So -3 plus 12, that gets me 9, equals b, because remember the 12s cancel out, so b is all by itself. So now I know what the y-intercept is. It's 9. And I know what the slope is. So I'm going to go back to my equation, and I'm going to write it. So now I'm going to go back, remember x and y, go back to x and y, because these are changeable. A line is infinite. There are infinitely many coordinates, meaning x and y combinations, within this equation. So that's why we leave them x and y. -3, that was the slope they gave me, and 9, which is a +9, I just found that for my y-intercept. So this is using slope-intercept to write an equation given a slope and a point. All right, so now we're going to look at point-slope form. So we were just looking at slope-intercept form. Now we're going to look at point-slope form. So hopefully you kind of get the idea. These are not terribly creative, or the names are not terribly creative. I'll say it that way. I kind of lost my words for a moment. So slope-intercept form, you get a slope and a y-intercept. And that's why it's named that way, because you can very quickly grab those two things out of that equation. So in a point-slope form, we're going to be given a point and a slope, right? Makes sense. So point-slope form is used when writing a linear equation given the slope and one of the coordinates of a point on the line that is not the y-intercept. So we're given another point on the line. We just practiced this, right? The very last slide was we were given a point and a slope, and we used slope-intercept to find the y-intercept. Well, we can actually use this equation right here without having to find the y-intercept. We can plug it right into this equation and create an equation very quickly, just like we would with a slope and a point, a slope and a y-intercept. So with this one, we want to identify the given information. I need to take all the bold down so this is a little easier to read. So it says identify what's given. It's just kind of running together there. So first I'm given an x and a y, and I'm given an m, which is the slope, right? So we want a line that passes through the point -9 and 7. Remember, a coordinate is always x then y. And we have a slope of -4/3, m. So if we look at point slope, it's a little bit bigger of an equation. It's not just y equals mx plus b. Now it's y minus a y coordinate equals m, the slope, times the difference of x and an x coordinate. So if you notice, the y coordinate goes with y, the x coordinate goes with x, and they're subtracted from each other. So we're literally just going to plug these in. We have x and y. This is x1 and y1 when we're looking at the coordinate here. And then we have a slope. So we're just going to plug them in. So it says make a plan. We're going to use them in the equation. Sorry, again, I need to take all this bold down. This is a little too crazy looking. So we have y minus y1 equals m times x minus x1. So I'm just going to plug them in. If I know y1 is 7, then here's 7. If I know m is -4/3, here's my m. And x is -9. Now the reason this second one popped up so quickly, I just didn't get through talking quite fast enough, is because we don't want to leave it -9 like that. We need to correct that. Whenever I have a double negative, I need to turn it into a positive. If I had +-9, I would have to just turn it into -9. So make sure you clean that up, because Alex won't let you type in two operations like that. It's not going to allow that. You'll have to simplify it. So we've written the equation in point slope form, and we don't need to go any farther than that. Now if I wanted to turn this into y-intercept, which is something that they may ask us for in the future, we would distribute this -4/3, meaning I would multiply both by -4/3, and then I would add 7 from the left to the right. And that would get me y equals, and I would have an expression on this side with the mx plus b. So we can quickly kind of manipulate or change them back and forth as we need to. All right, so let's practice that down here. We're going to have a line passing through point 8, -1, and a slope of -5/4. So first, identify what's given. We have x, y, and m. So I have a coordinate of x, y, and I have a slope of m. Make a plan, which this plan is exactly the same. We're going to use the equation, and we're going to plug in x, y, and m. Remember, it's x1 and y1 because it's the point that we're given. We still need an x and a y in our equation because there's infinitely many coordinates within this equation or within this line, and we need to be able to, plug in any possibility of x and find out what y is, or we can plug in any possibility of y and find out what x will be. So we're just going to change these up. So I have y minus y1 equals m, which is 5/4, times x minus x1. So again, you see a second one popped up here, and that's because we have minus -1, so we have to change that to a +1. So we just have to make sure that we're paying attention. Anytime we see that minus negative, we need to correct that before we enter it into ALEKS. All right, so that was point-slope form for writing an equation given a point and a slope. I hope that helped, and I will see you in the next video.